This lesson covers DNS records, which are really what enable the mapping of host names to IP addresses. These records live within a specific zone, which is a portion of the DNS namespace, and there are many different types of record. Some of those common records you will see are host records or A records. These actually map a name to an IP address. And if I double click on one of these, for example, you can see it has the host name, so it's going to use the parent domain for the rest of it, so the fully qualified name is that host plus the name of the DNS zone. And then its IP address. I can also say update the associated pointer record. So the pointer record is the record that exists in that reverse lookup zone. Notice it also has a time to live. So when different DNS servers or clients get this record and cache it, this is the amount of time that it's allowed to cache it for before it's considered stale, i.e. they need to go and recheck that record to a DNS server. I also have alias records. So an alias is really, as the name suggests, just another name for an existing record. The official name is a CNAME. So for example, it's very common when you visit a website, you type in www.company.com. The reality is they don't have any server called www, but instead what they will have configured are a number of back-end servers which have their own host names, and then the www is an alias which actually points to all of those different servers. For example, if I actually do an NS lookup on www.microsoft.com, we actually see the alias is www.microsoft.com, but in reality it's pointing to this server. So this is what makes use of aliases. There are also many other types of records. Now we can manually create these records. I can say a new host, a new alias, a mail exchanger, an MX record. This is how you can actually find the mail server for a particular domain. So when my mail server wishes to send an email to, for example, Microsoft.com, it does a search for the MX record for Microsoft.com. I can create delegation, domain records, or other types of record. So this is a list of all the types that are available to me. Now, one of the most important ones, particularly for Active Directory, are resource records or service. So this actually allows us to publish a particular service so clients can look up, I need a service. And this is used heavily by Active Directory. If I navigate, for example, to TCP, you can see a lot of service records, and these are how clients actually find, for example, a global catalog. They do a lookup for a service record of type GC. So let's look at this. If I go into NS lookup, I'm going to set the query to type service, and I'm going to look up _gc._tcp.saviltech.net. So you can see here it actually responds with those service records for that particular service. And this is how DNS is so critical for Active Directory. This is how clients find domain controllers, find global catalogs, find the PDC FSMO holder. They make DNS resource record lookups, or these service lookups. Now I can manually create all these different types of record, but the reality is with a common domain controller, it may register 40 different DNS records. Trying to manually create those would be very cumbersome. In fact, if you're curious, you can actually look on your domain controller and you'll find this netlogon.dns file. These are all the records that your domain controller registers when its netlogon service actually starts up. So if I actually look at this file, can you imagine trying to manually create all of these records for every domain controller? If your domain controller changed its IP address, you'd have to go and update all of these. And so when you integrate DNS with Active Directory, and it's really a requirement for AD, you have something called dynamic update. So this enables machines to actually register their own records into DNS. So for example, if I look at my properties, you'll see dynamic updates are allowed, but it's secure only. So what this ensures is that when a machine registers a record in DNS, someone else can't come along and change that record or try and intercept that. So it's actually using that Active Directory integration to ensure security. And you can set this on all those zones you create if you wish to allow dynamic updates or not. Clients use this as well. So because DNS is so important for things like mutual authentication, I need to verify this IP address is really this host, clients will also register their own records into DNS. For example, you can actually force this to happen. I'm on my Windows 8 box here, and I can again use that ipconfig command, and I can say register DNS. This is now going to take my IP configuration and re-register those records onto the DNS server. For example, if my IP address had changed, it's now going to go and re-register those records. Now again, this is not something you typically have to do manually. This will happen for you. But it's important to know you can trigger this manually if you wish. And again, you can now go and look at that DNS server and make sure those records have been applied. Now you may remember from our DHCP configuration, we did have these DNS options. So it may be the case where you don't want your clients to directly do dynamic update of their records themselves, in which case you can have the DHCP server do all of those on behalf of the client, or perhaps only update the pointer record. So you do have configuration here to control maybe blocking a client doing any dynamic update, enabling them to do some of it and the DHCP server do some. Or if you have clients, for example, that aren't capable, then for these older clients, I can say we'll do that on their behalf. So again, understand what you have in your environment and configure those right options for the integration with DNS. In the reverse lookup zone, you'll notice really I just have pointer records. These are the IP address to the data, the hostname records. There are some special types of records. You have these start of authority. So these are the servers that are authoritative for this DNS zone, and name server records, i.e. servers that are DNS servers for this zone as well. To test the records you've created, you can always use the NSLookup utility. So as we've shown in the past, I can actually leverage NSLookup and just type in my name. So for example, I want to find, is this server available? And that shows me. Notice it's not saying non-authoritative. I'm directly querying the DNS server that's authoritative for saviltech.net. Whereas if I search for something out on the internet, because I'm not directly talking to the DNS server for Microsoft.com, I get this non-authoritative answer. It's just telling me I've got that information, I'm giving it to you, but I'm not the authoritative server for that DNS zone. This concludes the lesson on DNS resource records.